Foucault's pendulum. In 1851, a French physicist, Jean-Bernard Léon Foucault, proved that our planet rotates. So what he did is he attached a heavy weight to the end of a steel wire, which was suspended from the dome of the Pantheon, which is this building in Paris, France. So inside that dome, he hung this heavy wire with the weight on the end. A pin fastened to the end of the weight rested on a circular layer of sand on the floor. Foucault set the pendulum swinging. The pendulum moved to and fro in the same plane. That meant if I pushed it straight forward, it was going to move straight back and kept going straight forward and straight back. And the pin at the end of the weight began to trace lines in the sand. So as the pendulum continued to swing, the lines followed different directions. There could be only one explanation. The pendulum did not change direction. Therefore, it must be the ridge of sand that was turning, since the sand rested on the floor of the Pantheon, and the Pantheon itself rested on Earth. Foucault concluded that Earth itself must be rotating. The Foucault pendulum that you are about to see is from the museum from the western part of the United States. The 240-pound brass ball suspended by a cable 40 feet long swings in a constant direction, while the earth beneath it turns. The pendulum is mounted to a bearing in the rotunda ceiling, just like we saw on the Pantheon building in Paris, France, that does not turn with the building as it rotates with the earth. So that pendulum, if I push it forward, it's going to come straight back and forth. It's not going to change its direction. Only the building as it rotates with earth does. So let's watch. So if I'm pushing it from left to right, that is the plane it's going to continue on. So what we know is that the theory is an object in motion stays in that motion. So if I push something in a straight direction, it's going to continue in that direction. It's not going to change direction. Okay, so this is a Foucault pendulum in a museum on the western part of the United States. Now, this is a professor from Dartmouth University, and he's going to explain about how the Foucault pendulum works. So please pay attention to what he has to say.
A Foucault pendulum is a pendulum with a specially designed pivot, designed so that it can swing back and forth in any direction around the vertical. So that's in contrast to, for example, a grandfather clock, where the pendulum has to swing in a particular plane. Let's imagine that you have a Foucault pendulum and you're at the North Pole of the Earth. When you set the pendulum swinging, you determine a plane in which the pendulum is swinging. And that plane is fixed. So as the Earth rotates underneath the plane of the pendulum swinging. And so if you now go back and imagine that you're standing on the Earth, you see the plane of the pendulum rotate every 24 hours. Now as you go...
So last but not least, this is a Foucault pendulum that is time-lapse. So it's like it's on fast forward. So they're going to push this Foucault pendulum in motion. And remember that theory, an object in motion stays in that motion. So nothing under the pendulum is making it move. The earth is rotating, and that is why it appears the pendulum is moving around in a circle. So please watch this. So this pendulum technically is just moving back and forth, back and forth. But as you watch it, it starts to appear as if the pendulum starts moving this way. And that is not the case, because the theory says if I move something, an object in motion stays in motion. It does not start turning. So over time, it appears as if the pendulum is moving, but in all actuality, it is the earth rotating, and it's actually rotating west to east, but appears to be, to our naked eye, east to west. And so this was the actual experiment that proved that earth rotated. And that was in 1851 that they had figured this out. Pretty amazing, if you ask me.